Unit 4 Exponential Functions. We will start with irrational exponents. So in example 1, here I have the equation 8 to the power of 3 over 7, and I'm going to rewrite this in a radical notation. This equation will be converted into the 7th root of 8 to the power of 3. This means that the number you multiply by 7 times will give you 8 to the power of 3 as your answer. In example 2, I'm going to do the same thing except with two radicals being divided. Since the radicals have been the same index, which is 3, I am able to combine their bases. I will simply divide 12 with 2 and keep the 3 as the index number. My final answer will become the third root of 6. Now we'll move on to properties of exponential functions. Here we have two graphs. They both explore the properties of exponential functions. The properties state that if a is greater than 0, then b is greater than 1. The graph is increasing. If a is greater than 0, but b is greater than 0, but less than 1, the graph is decreasing. If a is less than 0 and b is greater than 1, the graph is decreasing. And finally, a is less than 0 and b is greater than 0, but less than 1, the graph is increasing. In graph 1, I have the function negative 2 times 4 to the power of x. Since a is less than 0, but b is greater than 1, the graph will be decreasing, and a reflection will also occur because a is negative. In graph 2, I have two functions. I have the function 2 times 1 over 2 to the power of x. Since a is greater than 0, but b is greater than 0, but less than 1, the graph is decreasing. Transformations of exponential functions. Here I have the function g of x equals negative 2 brackets 1 over 2 to the power of x minus 3 minus 2. Its base function of f of x equals 1 over 2 to the power of x. The transformation that occurred to the base functions are the reflection on the y-axis stretched by 2 units shift 3 units to the left and 2 units down. Here are the values of the base function of g of x. As you can see here, the transformations being applied can be seen through the tables as well. Applications of exponential functions. A town has a population of 50 people. The population doubles every 3 years. What is the population after 12 years? First, I determine my variables to create my equation. I found the x value by dividing the total time by 1 unit of the total time. After that, I put my values together to create the equation after I solved for y. Therefore, the population of the town would be 800 after 12 years. Now moving on to exponential decay. You buy a new truck for $24,000. The value of the truck decreases by 16% each year. How much will the truck cost in 8 years? This example involves a percentage value. Because of this, I will be using the equation y equals a in brackets 1 minus r to the power of x. First, I determined my values for the equation and solved for y. Therefore, the truck is worth $5,949.02 after the 8-year period.